This building at the University of California, Santa Barbara may look relatively normal, but one corner of it houses a 3-story high aluminium sphere that provides a multisensory experience available nowhere else. It is the Allosphere, a kind of spherical cinema screen that scientists can step inside to explore their data in 3 dimensions. As a person stands on the bridge through the sphere's center, scientific data ranging from brain scans to molecular models is projected onto the dome around them. Thanks to special glasses, it all hangs in the air in 3D in front of the user, and a person can use a wireless controller to explore the data and gain a new perspective on the research.
Think of the Allosphere as a large, dynamically varying digital microscope that's connected to a large computer. So if we could take the data that we get from different instruments like fMRI machines or atomic force microscopes, take the mathematical calculations that come from their computations from supercomputers and actually visualize them and then look at them through this large 3-story microscope that will allow us to interact with the data both visually and audio. One example would be our material scientists who do experiments. They're usually working with different elements, different atoms, and they do an experiment to try to find a new material, and then they do computational simulations on that experiment. So we can take the numbers and we can take that data and that math and visualize it and sonify it, so they're actually going to be able to see data that's really too small for them to see from their quantum instruments.
This simulation is being used to study hydrogen bonding in a new material that could be used to make solar cells. The coloured strands show how the density of charge varies around a hydrogen bond in the centre of the molecule. Other data being explored today includes this brain scan, capturing activity while a person looks at photographs. The Allosphere team's goal is to make it possible to represent any kind of data at short notice.
We're building a general-purpose computational framework, which is different typically than what you have out there in the world that is working with particular applications, building software maybe that will work with biological data or chemical data. We're really trying to build a software framework, the mathematical algorithms that will allow you to put together any type of data, whether it's chemical data or physics or even abstract art. So the idea of having a general-purpose system, having the software framework be built so that it's generic enough to be able to work with different data types is really important.